All right, guys, this is the last lecture in Chapter 17. This is Module 58 on risk analysis. Let's get started. In this module, we are going to explain the processes of qualitative versus quantitative risk assessment. We also understand how to determine the amount of risk that can be tolerated in a population by humans, discuss how risk management balances potential harm against other factors, and look at the innocent until proven guilty principle when it comes to risk and human health and the precautionary principle. So risk assessment estimates basically the potential harm. We talked about how we determine how harmful a chemical is, how we look at viruses and things like that. So what we'll do with the risk assessment is first, we will identify the hazard. We'll characterize the toxicity if it's a chemical with a dose response study, and then determine the extent of exposure. How much exposure is there likely to be? Then we'll look at the acceptable level of risk. If it's not a harmful chemical, if it's in low concentrations or even medium concentrations, if it's not going to cause harm, we would accept higher amounts of that chemical. But if it's going to be very harmful, what level of risk are we willing to take with that chemical? All right. And then we go into risk management, which is where you develop the policies, the environmental protection laws, the different things with input from private citizens and industry and interest, with the scientific backing and the data to tell you how risky it is. So this is the process of risk analysis. So if you look in the United States, and we've talked about this a little bit before, but if you look at the probabilities of death in the United States, there are some things on here that people just perceive automatically to be dangerous. So some causes of death that people perceive as having a high probability of occurring, like getting in an airplane crash or different things that you see in there, bicycle accident or an earthquake or a flood, these things that are fairly rare. They don't have much risk, honestly. So they have a very low probability of occurring. In contrast, some causes of death that people rate as having low probability of occurring, such as dying from heart disease, actually heart disease is the #1 killer in the United States. So it's very interesting, people's perception of their risk. So there are two types of risk assessment, qualitative and quantitative. Qualitative, usually you don't associate with numbers, right? So in a qualitative assessment, we make judgments that are based on our perceptions, but are not based on actual data. Because of our personal risk assessments are not quantitative, they often do not match the actual risk. Like we said with being in an airplane accident or a crash or something like that. It's not very risky, but a lot of people, when they get in that airplane, automatically get nervous. All right. A quantitative risk is something that's much more useful in terms of science because it uses actual data and gives you an actual numerical risk for what's going to happen. So risk as itself is equal to the probability of being exposed to a hazard. So how likely are you to actually be exposed to this hazard? Multiplied by the probability of being harmed if exposed. So yes, you're going to be exposed to if you're really close to it and there's a lot around it, you're going to be exposed to it. Now, how harmful is it? Those basically multiply together to give you the level of risk. Risk acceptance determines how much risk can be tolerated. Some people are willing to live with risk and others are not. Even among those who are willing to accept some risk, the precise amount of acceptable risk is open to heated disagreement. Environmental scientists, economists, and others can help us weigh options as objectively as possible by providing accurate estimates of costs and benefits, basically quantitative analysis. A key factor in determining the type of chemical regulation is whether the regulations are guided by the innocent until proven guilty principle or the precautionary principle. So these are two different principles. Innocent until proven guilty principle is a principle based on the belief that a potential hazard should not be considered an actual hazard until the scientific data definitively demonstrates that it actually causes harm. And here's the problem with that. You're like, okay, that makes sense, right? We don't know if this thing causes harm. So we're going to go ahead and use it. The problem being, if you haven't done the studies on these chemicals yet and you start using them, it's determined later that it is indeed harmful. Then you've impacted a lot of people, made a lot of people sick, maybe even caused death because you did not test your chemical beforehand. So this leads to the precautionary principle, which is a principle based on the belief that action should be taken against a plausible environmental hazard. That basically you need to test these things out. You need to do your LD50 studies. You need to actually do your ED50 studies even on these chemicals to see if there's going to be any harm done to things that are exposed to these. And if so, how can we limit the exposure as much as possible? So the innocent until proven guilty principle basically starts with industrial research and development, limited or no pre-market testing, then post-market testing. It's already in the market, it's already been exposed. If it's found to be unsafe, you stop production of it. And then, so it's found unsafe there. Regulations and bans on unsafe products, then whatever makes it through there is considered a safe consumer product. But here, what we've got is products available to consumers, and so that can be pretty bad. All right, so the precautionary principle, though, you have industrial research and development. All right, you've got extensive pre-market testing with only the safest products being brought to market. So anything that's found unsafe is found here before any human comes into contact with it and consumes it. And so the only things that make it through are safe here instead of all the way over here. And then there's limited post-market testing required. All right, so there have been international agreements on hazardous chemicals. The Stockholm Convention was a 2001 agreement among 127 nations, so most nations in the world, concerning 12 chemicals that needed to be banned, phased out, or reduced. And so they all decided to reduce these chemicals, and over time, a lot of these things have been reduced. However, people come up each and every year with new pesticides, with new insecticides, because the old ones aren't working. And because of biological resistance to this stuff, we're going to talk about that in the next unit. So this is constantly changing. People are constantly developing new chemicals that can be harmful. REACH is a 2007 agreement among the nations of the EU about regulation of chemicals. The acronym stands for the registration, evaluation, authorization, and restriction of chemicals. And that's all for Chapter 17, which was human health risks. And we have Chapter 18 left, plus a little bit of Chapter 4. So, all right.